just inside the water gun, and this point 2 just outside the water gun. I'm going to use Bernoulli's equation again, because I've got really liquid flowing in a pipe, so to speak. So P1 plus 1 half rho V1 squared plus rho G1 equals Notice every single time I write everything out until I'm certain I can, before I eliminate things in my head so I don't miss anything. Okay, the problem is asking for gauge pressure, right? Typically that is represented as what? Rho GH, or the amount of pressure above atmospheric pressure. Okay. Well, let's keep that in mind as we look at this. So P1, do I know what P1 is on the inside of the?
No.
I don't. Okay, so don't know what's going on. Is there a height difference between the front of the gun and the back of the gun? They say the reservoir and the nozzle are level, so I can take care of that. What is the pressure a water molecule faces just as it leaves the gun? Atmospheric pressure. So P2 here is actually atmospheric. So P1 plus 1 half rho V1 squared equals P atmospheric plus 1 half rho V2 squared.
And it says you can assume that the velocity while it's inside the gun is 0.
Mm-hmm.
To be able to cancel.
So they give you an assumption that this velocity is 0 just at as it leaves. Yes? So I end up with this. Is everybody comfortable with that given the assumptions of the problem? How we pared the big long thing down? So think about what they're asking for. They're actually asking you to find this value. Typically, gauge pressure is due to difference in position, rho GH, but in this case it's not due, this difference, remember, this is the amount above atmospheric that we're looking for, is not due to a difference in position this time. It's due to a difference in velocities of liquids, or in and out of the object. So this is what we're after, and if we can find this value, we will have answered the question. This is just looking at Bernoulli's part of it. Now I have to go back to kinematics, right? Anyone? Thank you. So let's check it out. So realize I've got a projectile essentially going like that. It covers what, 7.3 meters? What do I know about my mass coming off of the desk? We did this in lab, yes? Zero acceleration in the x direction, correct. So do I know the velocity of this thing? No, that is V2. I do not know it, but I might be able to find it. Okay. And if you recall, when something rolls off the desk or comes out of the gun or whatever, its velocity in the y direction initially is 0, and it takes some amount of time for it to hit the ground. We need that time to help us find V2. So do you remember how to do that? Y minus y naught is equal to V naught y times t squared. That's my general equation, you guys remember? And my displacement is negative 0.75 equals 0 plus 1 half 9.8 times t squared. So you can find the time. We've probably done this at least 5 or 6 times, right? Even up here. What do you guys get for time? Somebody?
.15 seconds?
Nope. Did you take the square root?
Oh, oops. 0.39 seconds?
Yeah. So now I can find V2 because V2 times 0.39 equals what? 7.3. So V2 is and now I can solve the problem. The gauge pressure is 1/2 times 1,000, that's the density of water, times 18.7 squared. And you'll get 1.7